In any one-dimensional random walk or one-dimensional diffusion problem, the diffused distance grows in proportion to the square root of the number of steps. The number of steps is usually proportional to time, so that means that the diffused distance grows in proportion to the square root of time. There's a nice experiment, often done over several days in schools, in which one places a dense gas, bromine, which is a yellowy-brown gas, inside a tube full of air, and then you watch the interface diffuse in time, and you see that the distance it has moved grows in proportion with the square root of time. Boundary layers are also caused by diffusion. This time, though, it is diffusion of momentum rather than diffusion of bromine. And the diffusion problem is almost one-dimensional because the predominant direction of diffusion is in one direction, which is vertically up, the way I've drawn it here. So if we have a plate moving at speed v, and we impulsively start it at time t0, and then we mark the position of the edge of the boundary layer, we see that this thickness, delta, which is the thickness of the boundary layer, increases with the square root of t. So delta, the thickness of the boundary layer, is proportional to the square root of t. And that's simply because this is a one-dimensional diffusion problem in which horizontal momentum is diffusing vertically through the fluid. And similarly, if the fluid is moving at constant velocity over a stationary flat plate, then the thickness of the boundary layer increases in proportion to the square root of x, where x is the distance from the front of the plate. So if the free stream speed is v, and that's constant, then the boundary layer has a velocity profile that has zero velocity at the plate and v in the free stream, and has this velocity profile, that is free stream velocity v all the way down to the edge of the boundary layer, and then a lower velocity inside the boundary layer, which has thickness delta. And delta, the boundary layer thickness, grows in proportion to the square root of x.